Greetings and welcome to What's New in UIKit. I'm Dima, an engineering manager on the UIKit team. From iOS and iPadOS to tvOS, visionOS, and Mac Catalyst, UIKit continues to be the foundation of your apps, now with even more enhancements. I'll start off by giving you an overview of UIKit's support for the new design system. Then, I'll cover improvements for your app's content to adapt smoothly across various devices and screen shapes. Following that, I'll introduce new UIKit APIs for the menu bar, the familiar macOS element that's come to iPadOS. I'll dive into the core architectural advancements in UIKit, revisiting key fundamentals along the way. Finally, I'll wrap up with the broader general framework enhancements we've made. The new design system introduces a vibrant look for system materials and controls. At its heart is the new material, liquid glass. It's translucent, dynamic, and alive, with effects like specular highlights and refraction. From bars and search fields to alerts, popovers, and split views, UIKit standard components have been refreshed with the new material. Navigation slide transitions are now fluid and interruptible, giving your app a more responsive feel. Users can start interacting with content without waiting for the animation to finish. And to elevate your own UI to the new design, we introduced new tools like the background extension view, which allows your content to surface under the sidebar's large glass platter, preserving visual continuity. There is also a glass material for your own custom components. And the new scroll edge effect for your content to gracefully fade as it scrolls under the glass platters, enhancing legibility of bar buttons and other controls. For a comprehensive hands-on guide to updating the look of your UIKit apps, watch the video Build a UIKit app with a new design. And to dive into the new design itself, check out Get to Know the New Design System. Next, an overview of improvements for your app's content to adapt smoothly across various devices and screen shapes. In iOS 26, UI Split View Controller gains first-class support for inspectors. An inspector provides additional details of the selected content. For example, Preview uses an inspector to display metadata alongside the photo in the secondary column. You can now also resize columns by dragging the Split View Controller's separators. When using the pointer, its shape will adapt to indicate the directions in which a column can be resized. For more information on the improvements to container view controllers, as well as a refresher on general layout concepts, such as layout margins and safe areas, check out the video Make Your UIKit App More Flexible. Next, on the menu. iOS 26 brings the menu bar from macOS to iPad. Now, a swipe from the top reveals your app's full menu, even without a hardware keyboard. It's a great way to provide quick access to the functionality in your app. The menu bar supports all menu features, images, submenus, inline sections, checkmarks, and more. It should show all commands from your app, even those without keyboard shortcuts. And it keeps unavailable commands visible, but disabled, so users can still discover everything your app is capable of. Apps still use UI Menu Builder to customize their main menus. And in iOS 26, UIKit is introducing several new APIs to build even better menu bars. I'll start with the main menu system configuration. This API allows apps to customize which system commands are initially provided in the main menu. When you use the configuration API, your app is opted into additional pre-made localized menu elements, like the new command to toggle inspectors. And it lets you declare upfront which items to include or omit. You can also deeply configure and style individual groups of elements, for instance, optimizing defined commands for the needs of your app. Finally, supply a UI menu builder block ahead of time to add custom items, letting both your app and its share extensions use the same code to define supported keyboard shortcuts. This is an example of using a main menu system configuration. First, I create a configuration object. Then I specify which commands my app wants in the main menu by default. For example, I'll declare support for the system printing commands. I'll opt out of certain default commands, such as the new command to toggle the inspector panel. The configuration allows me to specify command styles for the default commands, like converting the system find commands into a single search item. This is great for photo or music apps, where the focus is on searching content rather than searching text. Finally, I can set the configuration on the main menu system to have it built with the initial set of preferred elements. I can also optionally provide a build handler, which will be called instead of build menu with builder. The handler provides access to a UI menu builder, which has been upgraded in iOS 26 with more powerful convenience methods, faster performance, and improved diagnostics. Note that setting a configuration will trigger a rebuild of the menu bar. Ideally, your app should set the configuration only once and as early as possible, such as in application.finish launching with options. iOS and macOS 26 introduce additional standard actions and menus in the menu bar. Perform close is mapped to Command W and closes your window scene by default. But you can also have it close other things in your app, like tabs in a web browser. The menu command new from clipboard allows creation of documents from the contents of the pasteboard without triggering a paste alert. The new item menu introduced in iOS 26 is a great place to put it. The standard actions for text alignment, sidebar toggling, and inspector toggling are also now exposed for your apps to customize. By default, keyboard shortcuts repeat when the keys are held down, but you can customize that behavior by setting the repeat behavior property on UIKit command. This property can also be set per responder using validate command. This is especially important for destructive actions like hitting a delete key to delete an email, so you don't accidentally trigger them repeatedly. In some cases, parts of the menu bar need to display dynamic content based on the focused item or a window scene. For example, browsing apps like Safari may show history for the current browsing profile in the history menu. To support this, use the new focus-based deferred menu element, which populates its elements from the responder chain. When constructing your main menu, create a UI deferred menu element using focus, and give it an identifier to differentiate it. Then, insert it into the main menu. When the deferred element needs to be fulfilled, UIKit walks the responder chain until it finds a responder that can contribute items. In this example, the browser view controller overrides provider for deferred menu element to supply history items for the current profile. It checks the identifier of the deferred element for the browser history element and returns the provider to load history menu items. Focus-based deferred elements are a great way to keep the menu bar up to date with keyless commands, without needing to perform costly rebuilds on the main menu system. Beyond your app's custom items, the system supplies several menu entries automatically. Your app gets a keyboard shortcut to open settings in the Settings app, and for document-based apps, the Open Recent menu will be populated with recent documents. The system also supplements the window menu with tiling commands, including a list of all open scenes for your app. Populate the title of each scene to help users differentiate them. Finally, a few things to keep in mind as you build out your menu bar. For UIKit apps, menu bars defined in storyboards are no longer supported. Apps will not launch with menus and storyboards, so implementing them programmatically is required. You should also ensure that your app's functionality remains accessible without the menu bar, since the menu bar will not always be present. To learn more about how to build a great menu bar for your app, watch Elevate the Design of Your iPad App. And for an overview of the UIKit main menu, check out Take Your iPad Apps to the Next Level. We are continuing to evolve UIKit with new features for modern patterns, best practices, and deeper SwiftUI interoperability. iOS 26 is no exception, and I have exciting new architectural improvements to share with you. The first major enhancement is built-in support for Swift observable objects in UIKit. UIKit now integrates Swift observation at its core. In update methods like layout subviews, it automatically tracks any observable view reference, wires up dependencies, and invalidates the right views. No manual setNeeds layout required. You can back deploy this on iOS 18 by adding the UI observation tracking enabled key to your info plist. On iOS 26, it's enabled by default. I'll go over a couple of examples of automatic observation tracking in action. Here I have a message list view controller containing a UI label that indicates unread messages. It's backed by an observable model object with two properties, a boolean that controls whether the status is shown, and the status string. In view layout subviews, I use the observable model to update the label's alpha to show or hide it, and set its text. On first layout, UIKit populates the label, and, thanks to automatic observation tracking, records dependencies on show status and status text. Any change to those properties invalidates the view and reruns view layout subviews, keeping the label in sync without extra code. Here is another example of using observable objects with UIKit, which highlights the benefits of automatic observation tracking when configuring cells in a UI collection view. I back each list cell with an observable list item model containing an icon, title, and subtitle. Inside of the cell provider callback, I dequeue a cell, grab its model, and assign a configuration update handler. Because this handler supports observation tracking, UIKit automatically establishes dependencies on any observable objects I use inside it. In the handler, I populate and apply a list content configuration using the observable list item model. That's it. Now any change to the model's properties while the cell is visible causes UIKit to rerun the handler and update the cell for me. With the addition of automatic trait and observation tracking, UIKit now includes a general-purpose update method to support those features. We introduce a new method, update properties, to both UIView and UIView controller. It runs just before layout subviews, but is independent, letting you invalidate properties without forcing the layout, and vice versa, so you avoid extra passes and gain fine-grained updates. Update properties complements, not replaces layout subviews. Use it to populate content, apply styling, or configure behaviors. It automatically tracks any observable you read. And you can manually trigger it by calling setNeeds update properties. I'll go over a concrete example of using this new method. Here I have an observable badge model object that stores the count displayed in a badge view. The view controller for the bar button item is backed by a badge model. Within update properties, I use the new badging API on the bar button item and pull the count straight from the model. Now, whenever the observable model object changes, it results in update properties running and updating the badge. By using update properties to configure the view instead of layout subviews, I avoid rerunning the code on unrelated events like resizing, cutting unnecessary work, and improving performance. To better understand how your update properties fits in with other update methods, I'll go over how UIKit's update path works. Here is an illustration of how UIKit updates views before displaying them on screen. The layout path comes first. UIKit traverses the view hierarchy top-down, updates each view's traits, then calls layout subviews. If that path causes other views to require layout, the layout path repeats until everything is laid out. Once the layout settles, UIKit performs the display pass, calling draw method on each view, and repeating until all views no longer need display. Once both passes finish, the next frame can be rendered and displayed on the screen. And here's how the new Update Properties callback fits in. During the top-down layout pass, UIKit runs update properties right after updating traits, and just before layout subuse. You can think of layout subuse as being split into two stages: property updates first, then the usual layout logic. Because the trait collection is updated before update properties runs, you can safely read it there. And since it always precedes layout subuse, you can invalidate layout inside it, and the layout pass will run immediately afterward. To complement the new observation tracking feature and new update properties method, we've made an improvement to how animations work in UIKit. Before starting, I'll go over how a manual update works in iOS 18 and earlier. In a UIView animation closure, first, the new values are set on observable objects. Then, layout, if needed, is called on views that depend on those objects. Both steps are necessary, because the first step causes an invalidation, and the second step performs the update and creates animations. Manually maintaining property and view dependencies is prone to error, and can result in either too many or too few updates or animations. iOS 26 has a new animation option for UI views called Flush Updates. When enabled, UIKit applies pending updates just before the animation begins, and again when it ends, so you no longer need to call layout if needed. For Flush Updates to work, only make invalidating state changes inside the animation closure. I'll go through an example of how to use Flush Updates. First, pass Flush Updates as an option to UIView Animate. Then make changes to the observable object inside the closure. Any views using that observable object in an update method will automatically perform the necessary update. Flush Updates isn't limited to animation driven by observable. Here is an example of using it to animate auto layout constraint changes automatically. In the Flush Updates closure, I set a new constant to one of the existing constraints, and also activate and deactivate other constraints. Dependent views animate to their new positions and sizes automatically. Now I'll cover how we made using SwiftUI and UIKit in the same app more seamless. SwiftUI scenes are now supported in UIKit applications using a new delegate protocol. This supports incremental adoption of SwiftUI and also allows UIKit apps to leverage immersive spaces and volumes on visionOS. Imagine a meditation app that presents a Zen garden scene in a standard 2D window on iPhone and iPad, and as an immersive space on visionOS. I present that immersive space by implementing the new UI hosting scene delegate protocol with a root SwiftUI scene. Using a hosting scene delegate is just like any other scene delegate. Simply set the delegate class type on the UI scene configuration when a new scene is connecting. You can programmatically request a particular SwiftUI scene from the hosting delegate by passing its identifier. In this example, I request the immersive Zen garden space. Lastly, I'll guide you through some general enhancements in UIKit, starting with improvements to HDR rendering. With iOS 26, HDR isn't just for images anymore. Colors get the same treatment, so you can accentuate your user interface or enable new experiences. UI Color now lets you specify a base HDR color plus an exposure value, automatically adjusting its brightness to the display's capabilities. Here, I create a red HDR color with its exposure set to 2.5 times the SDR's peak white. Now you can also enable HDR color selection in UI Color Picker View Controller and UI Color Well. To do that, set a maximum exposure to a value guided by your app's rendering capabilities. Here I set the maximum linear exposure of the color picker to be twice the SDR's peak white. In iOS 18, UI image view intelligently falls back HDR to SDR, ensuring that key content in the UI stands out. In iOS 26, this behavior is expanded to video, and your own custom content can participate as well. Use the new UI trait HDR headroom usage trait to monitor when your HDR content should fall back to SDR. To learn more about HDR, check out the videos Use HDR for dynamic image experiences in your app and support HDR images in your app. Building on an S notification name API, UIKit in iOS 26 now represents each notification as a dedicated notification sender message type. This gives you a strongly typed value for registering observers and for retrieving event details. Here is an example of adjusting the layout when the keyboard appears. I register for the keyboard will show notification type. Then, in the handler, I pull the animation duration and the keyboard frame straight from the message. Finally, I animate my constraints using those values. No need for user info lookups or manual casting. With each release, the continuous evolution of UIKit brings you modern, robust APIs for today's best practices. And as you adopt those, we're deprecating the legacy methods. UI scene adoption makes your apps portable and highly flexible, so we're deprecating many UI application-focused APIs. Legacy UI application delegate callbacks and UI application launch option keys no longer apply, and only the init window scene initializer for UI window remains. Every other initializer is deprecated. In the release following iOS 26, any UIKit app built with the latest SDK will be required to use the UI scene lifecycle. Otherwise, it will not launch. Adopt the UI scene lifecycle everywhere, not just in multi-window apps. For details on how to do that, read the tech note, Migrating to the UIKit scene-based lifecycle. For more information on how to maximize the flexibility of your app, including new APIs that will help you migrate away from UI requires full screen, check out the video, Make Your UIKit App More Flexible. Apps dealing with a variety of document types frequently need to launch external viewers. In iOS 26, the existing OpenURL method now accepts file URLs, so you can now hand off documents that are not natively supported by your app. If a default app exists for that file type, the system launches it and passes along your URL. If not, OpenURL returns false, giving you an option to handle the fallback yourself. For example, by using a quick look preview controller. SF symbols got improved in iOS 26. SF symbol 7 add the ability to draw symbols, starting with two new effects. Draw off, like the disappear effect, uses the draw animation to hide a symbol. Draw on, like appear, shows a hidden symbol by drawing it. Symbols can now support variable draw, a new mode for variable value. This draws arbitrary values along a path, such as for this progress indicator. You can also use it with the automatic symbol content transition to animate across variable values. Magic replace transitions can also perform special draw animations between certain symbols. For example, this transition between the circle symbol and the filled checkmark symbol now fills the circle and draws the checkmark. The new draw animations are incredibly useful for buttons, so UIKit is adding new API to easily adopt symbol content transitions in UI button. Use the new symbol content transition property on UI button configuration to specify a symbol content transition, such as replace. When the button symbol changes, say when its selection state toggles, UIKit performs the transition. SF symbol 7 introduces other capabilities too, like the new color rendering mode option. Apps can specify gradient to color their symbols using automatically generate gradients rather than flat colors. To learn how to fully customize drawing and gradients, watch What's New in SF Symbols 7. And for a refresher on how to use symbol effects for animation, check out Animate Symbols in your app. What's next? Compile your app using the iOS 26 SDK. Review how your app responds to the new design and refine your UIs and styling to match the new aesthetics. Use standard containers like UI Split View Controller and UI Tab Bar Controller to get support for flexible layouts. Implement your app's menus with the new menu APIs. And adopt Update Properties method and observation tracking to streamline your code and improve performance. Thank you. I'm excited to see how you use these improvements to make your apps even more powerful and delightful to use.